Find the derivative of f of x equals root x from first principles. And here we see the graph of f of x equals root x. To find f dash of x, we compute the limit as h tends to 0 of f of x plus h minus f of x over h. And we choose a point P on the graph where f of x equals root x, and a point Q where f of x plus h equals root x plus h. And so we obtain the limit as h tends to 0 of root x plus h minus root x over h. And to simplify this quantity, we rationalize the numerator, which we do by multiplying the numerator and denominator of the fraction by root x plus h plus root x. And if we note that the quantity in the blue box has the same numerator and denominator, then we see that we are multiplying the original fraction by 1, and so we are not changing its value, we are merely changing its appearance. And now we multiply the numerators and we apply the difference of two squares identity when we have done that, to obtain the limit as h tends to 0 of root x plus h squared minus root x squared over h times root x plus h plus root x. And on squaring the quantities in the numerator, we obtain the limit as h tends to 0 of x plus h minus x over h into root x plus h plus root x. And we note that the numerator simplifies to h. We now cancel the h in the numerator and the h in the denominator to leave us the limit as h tends to 0 of 1 over root x plus h plus root x. And the quantity shaded in green, 1 over root x plus h plus root x, is the gradient of the chord joining P and Q on the graph, shown in red. And now we apply the fact from the algebra of limits that the limit of a fraction becomes the fraction of limits, and so we obtain this expression. Now, the limit as h tends to 0 of 1 is 1, since 1 is a constant and does not vary with h. And we will see later that the limit of the denominator is root x plus root x, so we obtain 1 over root x plus root x, which is 1 over 2 root x. And so we have that if f of x equals root x, then f dash of x equals 1 over 2 root x. And here we have the graph of f dash of x, and we note that f dash of x is positive for all x, which corresponds to the fact that f of x is increasing for all x. And now we look at the limit of the denominator, which we did not deal with in detail before. We have the limit as h tends to 0 of root x plus h plus root x. And first, we split the limit of a sum into the sum of limits. And we note that root x does not depend on h, so the limit as h tends to 0 of root x is root x. Thus we obtain the limit as h tends to 0 of root x plus h plus root x. So now the question is, how do we deal with the limit as h tends to 0 of something inside a square root? Well, in fact, we can exchange the order of the square root and the limit, like so. And so we obtain the square root of the limit as h tends to 0 of x plus h plus root x. And from that we get the square root of the limit as h tends to 0 of x plus the limit as h tends to 0 of h by splitting the limit of the sum into the sum of limits once again. And since x does not depend on h, and as the limit as h tends to 0 of h is 0, we obtain the square root of x plus the square root of x, which is 2 root x, and we're done.